Hi everyone, I'm just getting things set up so that we can take a look at our next video in our Chapter 1, Sequences and Series. We're looking at, in particular, the applications of the arithmetic sequence and series in this video. So basically, we're going to take a look at what it's like to apply the arithmetic sequence and series to solve real-life applications. In terms of vocabulary, just make sure that you're watching for and making sure that you can distinguish between arithmetic sequences and arithmetic series. We're going to be taking a look at a number pattern called the superstairs. It's basically an exercise program. And so to start with, let's just play it once. Okay, so there you have it. The first one being a video of this fellow just running up the stairs. And the second one showing you this exercise pattern called the superstairs. Oops, sorry, we don't need to see it once again. Now, the question I'm going to ask you is how many steps will he take on the superstairs exercise routine or program? So I'm making a distinction. Steps means the actual physical motion. Stairs would be the actual step, the thing that you step on. So we want to know how many steps will he take as he follows this superstairs exercise routine. So the first thing I had you do in class was to write down a guess and share it with your neighbors, something that you felt was a ballpark figure of what it could be in terms of the number of steps he will take as he runs up and down in this superstairs pattern. And then I asked, what information would you need to answer with more accuracy? What would you need to know to be able to calculate this mathematically? And people suggested different things, but I think everyone felt that they would need to know how many stairs there were in this particular physical stairway. And then we would have to once again kind of clarify what the actual routine was to his pattern and talk about that a little bit more. So let's take a second look. And this time I want you to be looking for the number of stairs and then watch the pattern really closely. Okay, so I'll probably play this again. Hang on, and we'll go on. So first of all, I think most people counted, and we've done it so many times, I'm pretty sure that there are 21 steps in this stairway. And when we talk about the pattern of what he's doing, you'll notice that in the first one, he steps up and he steps down. Now, he does take sort of a little dance step at the bottom, and we decided that we would ignore that. So if we're talking about the first term, he's taking 2 steps. And then the second term, he's going up 2 of the stairs and coming back down. So he's taking 4, and so on. Our sequence is looking like the following: 2, 4, 6, 8, 10. So what type of sequence is this? And explain your answer. If you look back at it, you can see that this one is arithmetic. Its first term is 2, and it's got a constant of 2 that we are adding to each one of the numbers. So if I were to say, find the formula for this one so that we actually figure out what it looks like, we would put in our first term plus n minus 1 times the constant. So we'd have 2 plus, and then if we distribute this, 2n minus 2. So really our formula, the general formula, is 2n. So when I ask you how many steps will he run in the super stairs, the question is, what are you actually looking for mathematically here? You are looking for the arithmetic series for 21 terms of this pattern. And so, in order to actually calculate what that is, we need to know the first term, which we know, but we also need to know the 21st term. So, I stopped and took a moment, figured out what the 21st term was, make sure that you stop and do the same. Turns out it's 42. Plunk it in along with the 2 and the 21, and we can multiply it. We should get an answer of 462 steps, okay, that he will take in the Super Stairs exercise program. The next problem we're going to look at is a pyramid that we are making of cereal boxes. And it goes like this. Jonathan has a part-time job at the local grocery store. He's been asked to create a display of cereal boxes. The number of boxes in the rows produce an arithmetic sequence. There are 16 boxes in the third row from the bottom and 6 boxes in the 8th row from the bottom. How many boxes are in the bottom row? So if we were to translate this, we've got a sequence going on. They tell us it's arithmetic. So we know that the third sequence, our third term, is 16, and that the 8th term is 6. And so if we use that mathematically, we would say, okay, the third term, here we go, 16 equals the first term plus 2 constants. The 8th term, 6, equals the first term plus 7 constants. Now, we've got 2 statements about the very same cereal box pyramid. So we can put them together and try to figure out what one of the terms is. I prefer elimination in a situation like this. So I put them on top of each other and I subtract. And when I do, I find, and please do pause the video and take a look at these numbers, I find that the constant is -2. Once I know the constant is -2, then I'm going to use one of my formulas. I chose to use this one to find the first term, and I plug in the constant of -2 and discover that the first term is 20. So the number of boxes in the first row of this cereal box pyramid are 20. What is the total number of boxes in this display? Now, we kind of had to go along with it a little bit and realize, okay, so we're coming, if we look back at our question a little bit, we're doing 20 and then 16. Is that the right one? Sorry. No, that's the third one. So 20 and then 18 and then 16 and so on. So we've got a constant of -2, a first term of 20, and really our last term that we're going to use, other than 0, of course, would be 2 cereal boxes. So let's see what it looks like. So we know this information because we figured it out. And let's take a look this. We need to know the number of rows that we actually have. So if we know that our last term is 2, first term is 20, and we use our formula, if we do the algebra carefully, we find that the number of rows is 10. Once we know the number of rows are 10, then we know we're looking for the sum of 10 numbers in this series. So it's 10 over 2, first term's 20, last term's 2. We know that there are 110 cereal boxes in this pyramid. The last problem in this particular video looked at the male firefly. And this is kind of a close-up picture. If you have a chance, I would encourage you to look at the following video. It's just a really cool illustration of the firefly and the way in which they flash. And it's such an amazing part of nature. So it says male fireflies flash in various patterns to signal location or to ward off predators. Different species have different flash characteristics, such as the intensity of the flash, the rate of the flash, and the shape of the flash even. Suppose that under certain circumstances, a particular firefly flashes twice in the first minute, 4 times in the second minute, and 6 times in the third. What is the total number of flashes in 30 minutes? So the first thing we need to identify is this arithmetic? We have term number 1, which is 2, term number 2, which is 4, and then 6. So yes, we have a very simple arithmetic sequence. So in order to find it for the number of flashes let's make sure we're doing that, in 30 minutes, we need to know the 30th term. So I'll plunk in the first term, 30 minus 1 times our constant of 2, and we find that it's 60. And then we go to find the sum of those 30 terms, 30 as the number of terms, 2 is the first, and 60 is the last, we find out that this firefly has flashed 930 times. Okay, there you have some examples of using the arithmetic sequence and series to solve real life applications. So please take a look at the homework and let me know if you have any questions at all.